Welcome to Blockchain Recorded, the podcast for the tech curious, where we talk about anything and everything related to the exponentially evolving crypto, blockchain, and Web 3.0 space. Our mission is simple: to share knowledge, facilitate discourse, and help evolve education in blockchain fundamentals, decentralization solutions, and relevant use cases for today's digital economy. We at Blockchain Recorded are not registered investment advisors and do not deal with financial or trading token elements, nor offer any licensed financial services. The content of this podcast is for informational and educational purposes only, while the opinions of all parties involved are their own. I'm your host, Nina Tserar, and now let's talk blockchain. Before I introduce our guest today, I'd like to remind our listeners to follow us on Twitter, where we pre-stream each episode on Twitter Spaces the day before publishing on all major podcast platforms. For the platform list, visit our website, blockchainrecorded.com. Today we have with us Keone Hon. Keone is the co-founder and CEO of Monad Labs, a team of system engineers bringing parallel execution and low-level optimization to the Ethereum Virtual Machine. Previously, Keone spent 8 years at Jump Trading, building a high-frequency trading system for major traditional finance futures markets. In 2021, Keone joined Jump's crypto division and led a team of engineers focused on blockchain research and dApp development. So with that, without further ado, Keone, welcome to Blockchain Recorded.
Thanks so much for having me, Nina.
Sure thing. So Keone, you have an extensive background, mainly in high-frequency trading. So in the TradeFi space, which means building high-performance trading systems. I sort of quickly glanced at your LinkedIn to make sure that I understood everything that you did: machine learning, quant trading, etc. First things first, what brought you to the world of crypto and later on founding Monad?
Yeah, I graduated from college in 2011 and immediately went into the high frequency trading space. It's a really interesting place with, just a focus on a huge amount of data coming back from the exchanges. And basically the problem statement is really just to find ways to digest that data and, lasso this chaos into something that makes sense, convert all this data into predictions about what's going to happen in the future. This was a really good experience. I learned a lot about building high performance systems and building very low latency systems. And those are kind of two separate axes because, there's an element of scale, like just exchanges sending back hundreds of millions or billions of messages per day that just one strategy has to digest. But then also for each of those messages, the system has to be really performant, really fast in order to be competitive in this purely automated trading space. I spent a number of years doing that and worked with really great teammates. In 2013, I joined Jump Trading, which is has grown into a major player in the HFT space, and just worked there for, I guess, about 7 or 8 years on the pure HFT side. And one of the things that our team traded was cryptocurrencies, both spot and derivatives markets. So my first exposure to crypto was actually just an asset to trade that had really interesting correlation structure and so many different coins, so many different derivatives, so many different exchanges. But then over time, working on that and, digging more deeply into the actual instruments being traded, that was kind of a transitional period for me and the rest of my team at Jump Trading. So spent a number of years doing trading, both in the non-crypto side and in the crypto side, and then joined the crypto division of Jump Trading in 2021, where we immediately kind of pivoted and started working on DeFi, exploring different DeFi protocols. And that was kind of what got us really crypto pilled.
Just tracking back to your decision for getting into high frequency or HFT, what was the decision behind that? I mean, I'm just thinking back to, you mentioned 2011, that back then, I'm much older than you are. So I come from the banking side in terms of Wall Street, but I don't remember, like in the early 2000s, having just the conversation with the traders that I was just speaking with. High frequency trading was just super niche at the time. What was it like back then, and what is it like now? Is it still more of a niche, sort of a sub trading industry or sub industry within the trading industry, or has it gained much more traction Or would you say also in relation to the crypto world, or does that have anything to do with it?
Yeah, I think it's still pretty niche. I think that the public awareness of it has definitely increased over the years with the Michael Lewis book, Flash Boys, which actually paints a really unflattering picture of high-frequency traders, but, everyone loves a villain as well. So, yeah, I think it's people are a lot more aware. I think in the, among new grads, from CS programs, there's a lot more awareness now than there was like 10 years ago. And probably the head count overall for the industry has grown from, I don't know, I'm just making up numbers here, but I think in 2011, it was probably like 5,000 people. And now it might be like 20,000 people.
Yeah, yeah. And was it more US Wall Street in terms of the high frequency, or would you say now it's a little more geographically spread, or do you know?
I think the US is still the
dominant,
most dominant in terms of, most of the really big HFT firms are US centric, maybe like have US founders, but American founders, but there are a couple of really big ones that are outside of the US, like XTX is really successful, originally like focused on FX trading. And I think they've branched out to a lot of other markets, but they're in London. Yeah. Yeah. There's some other players in the space. So then what made you decide to go for or start Monad? Yeah. Well, I think there's just thinking back on your previous question about like 2011, like how prevalent awareness of HFT was then versus now. I feel like there's just this trend of automation, like, using computers to do things is just a very natural, like obvious progression over time. So in the early 2000s and this is a little bit of a tangent, so I have to apologize, but I promise it'll get back to your question. Sure. Yeah. In the early, very early 2000s, like 1999, 2000, this is when exchanges, there were electronic exchanges before that, but this was when they first opened up and allowed, made it like the access to these exchanges became a little bit more broad. And so actually almost all of the successful HFT firms were all founded around the same time of 1999, 2000, 2001 or so. And it's because that was the moment when the exchanges started letting outsiders in. Like you didn't have to have a membership, or it was easier to get a membership. So it's kind of funny, in the history of HFT, in 2011 when I joined, it felt like it was pretty late, I guess, because, these firms had already been around for 10 or 11 years. And when I joined, people were talking about like the heyday of, 2003, 2004, and then the financial crisis had happened in 2007, 8, 9. So there was just so much volatility back then. And the feeling was like, we're still doing it, but, that was crazy back then. And so I think the two themes that I kind of draw from that are, one, that the early days always has like this Wild West feel, but then over time it gets more mature and more scalable and, hopefully provides much better services to the end user than in the early days. In the case of HFT, that's in the form of much tighter spreads than, in the early days of electronic trading. But then I guess the other thing is just that, it just gets more efficient. And so I sort of see crypto as being on a similar path where we had the, really Wild West days of DeFi summer in 2020. And before that, the first smart contracts getting deployed and the DAO hack and, just all of these things that have happened in our industry's past. And over time, the trend is obviously to get more efficient, more performant, better user experience in terms of DeFi, tighter spreads for people interacting with decentralized exchanges. But it's all coming from better technology, better automation. And, that sort of brings us to Monad. Like, why do this? It's because, our team felt that there was still a huge need to make the space more performant, and that a lot of other improvements would ultimately result from addressing the sort of most fundamental issue, which is the lack of transaction throughput in the Ethereum Virtual Machine.
And just one more general question I was fascinating with the name Monad. I don't know if I'm pronouncing that correctly. Monad. which I actually looked it up on Wikipedia because I didn't know what it meant. And early, it stems from the Greek philosophers, meaning, and also in Christian Gnostic belief systems, it means the one or the absolute or etc. So I gather it holds an important meaning in programming or computer science as well.
Yeah, it's a good name. We thought it was a good name for a number of reasons. One is that it's an uncommon common noun. So, it's like a real word, but it's not something that people have encountered a lot.
Yeah.
It's always a great name for something. And then, the philosophical and biological, I think in biology, it refers to like a single-celled organism or maybe even more granular than that. In computer science, it's a term used in functional programming. We actually don't do any functional programming in Monad, like in the Monad code base. But we used a lot of functional programming in the past in our HFT days. So I don't know, it gives us a lot of street cred with like maybe 5% of the people we talk to who are like, oh, monads, cool. I love monads. So that's kind of a funny thing. But overall, it's a good name that kind of captures the essence of the project, which is to build a singular, really performant blockchain network that can help advance the space.
Yeah, so let's dive into Monad. Your homepage description, if I can quote, so you describe Monad as a decentralized, developer-forward, layer one smart contract platform that ushers into a new paradigm of possibility through pipelined executions. So there's some key phrases there of Ethereum transactions. Tell us about Monad. What are you guys doing? What's your mission? And just if you could shed some light on how Monad is also different from other layer ones.
Yeah, when I think about the Ethereum scaling landscape, actually maybe first when I think about Ethereum, Ethereum set out to build the world computer. That means that there are thousands of nodes spread all the way around the world that all are perfectly synchronized with each other. They all have exactly the same state, meaning that they have all of the exact same applications installed. And each of those applications also has exactly the same application-specific state. And this shared global state is what really enables everything. It means that developers can build applications and then upload them to this quote unquote to the blockchain, aka to one of the nodes, which then ends up propagating it to all the other nodes. And anyone can then go interact with those applications. The applications can provide useful financial services like a virtual bank that allows people to go deposit money, earn interest on their deposits. The bank can go loan that money out to someone else who needs a loan. So, everyone wins because the bank earns the spread between the low rate on deposits and the high rate on loans. The borrower gets a loan that they can do something economically useful with, and you, the depositor, get interest on your loan. So, it's a thing, businesses exist to unlock value and create a sort of win-win situation for everyone. And the cool thing about decentralized shared global state is that it can enable people to build applications that add value, that create win-win situations for everyone. So that's like what Ethereum does, and it does it really well. It enables decentralized, like truly decentralized applications that aren't subject to the, whims of a single centralized authority. What it doesn't do as well right now, and what a lot of people in the Ethereum space are working on through different efforts, is the throughput of Ethereum is really limited right now, limited to about 10 transactions per second or 1 million transactions per day. And that's just very constraining limit given that there's 8 billion people in the world. So literally, if all 8 billion people wanted to use Ethereum at the same time, you could only use Ethereum, 8 billion divided by 1 million. So 8,000, one every 8,000 days. It's not good. So there are a lot of people that are trying to help scale Ethereum in different ways. And I think of the landscape of Ethereum scaling as, there's different verticals. There's people working on optimistic rollups. There's people working on zero knowledge rollups. There's people working on data availability solutions. There's people working on shared sequencing. And Monad is basically a new pillar in that landscape of Ethereum scaling efforts, which is an effort to make execution of the Ethereum virtual machine really performant. And we do that in a number of different ways, which I can elaborate on more in a second, but I just wanted to mention that at outset that Monad is a unique project because we're doing something that, to my knowledge, no one else is really trying to do, which is enable really performant execution of the Ethereum Virtual Machine, as compared to other layer ones or other projects where the focus might be more on proving systems like other fraud proofs or validity proofs or systems for storing data in a cryptographically verifiable way. These are different efforts that are all ultimately sort of pointing toward the same goal, which is to help Ethereum scale. We have different approaches. And then one of the good things is that a lot of these approaches are actually compatible with each other. They're orthogonal. And ultimately, I think the future will be a combination of some of these different technologies put together. I think that Monad's execution technology will definitely be a part of this overall Ethereum scaling effort.
And it's not like you're competing against Ethereum.
Exactly.
Right. Yeah. So, well, I know just from my reading and from my research, I know that you probably get this question a lot, and you actually, if I'm not mistaken, you wrote a Substack article because you mentioned rollups. Just for context, why is Monad not a rollup? I know for the sake of decentralization, it's one of the first main reasons, but I'll let you elaborate further.
Monad is a layer one, meaning that it's a sort of fully independent blockchain system that provides the same interface as Ethereum, both to applications and to infrastructure that's built on top of the blockchain. So applications like Uniswap or infrastructure like MetaMask or Etherscan can work interchangeably with Monad, same as they could with Ethereum. And the reason for that is that we think it makes the most sense to build a full solution, like a fully functioning system that can operate independently, because that ultimately offers the best performance and the lowest cost to end users. It's really important to have a North Star, and our North Star is minimizing the cost of transaction execution and maximizing the throughput that we can deliver, like the number of transactions that the system can process, while maintaining a high level of decentralization. And I mentioned that last part because, obviously there's a sliding scale. Like if you choose no decentralization, if you just have a single centralized server, then it's possible to deliver really high throughput and really low fees trivially because you can just buy a really beefy server. And then also with a single node system, there's no overhead of communication between servers. And, the world of decentralization that was introduced through Bitcoin and then Ethereum and, a whole lineage of projects that have shown the power of decentralized shared global state means that it's very clear that, highly centralized kind of solution on the extreme end of the spectrum where there's only one server, that doesn't actually really add value to what all of us in the crypto space care about, which is decentralized shared global states. So I just want to emphasize that the way to get to both high performance, low fees, and a high level of decentralization is by making algorithmic changes to the software, to how the software behaves, to how the nodes come to consensus, to how transactions are scheduled and executed, all these like more intricate details. Because of course one could produce a high performance system by cheating effectively by just having a single node, or perhaps by having the nodes all very close to each other geographically so that the overhead of communication is very limited. You see that sometimes with other systems. But having a truly decentralized system with hundreds of nodes, geographically distributed, that are all, hundreds of nodes participating in consensus, and then delivering that level of performance, that's what we set out to do. And that's why we think the work that we're doing is going to be, able to move the space forward.
Yeah. Before I ask you a little more in terms of what you're hoping to achieve and attract in terms of what kind of applications, I'm just curious, what's your view on the blockchain trilemma? I mean, do you think this is an outdated concept, or is this something that you, in terms of conversation, have frequently? It sounds to me like essentially you are trying to solve sort of the problem of achieving all three pillars of the trilemma. But just curious, what are your thoughts? Because obviously decentralization is a huge part, and then you want to tackle the throughput, and obviously, which part is it still that you have to sacrifice one of the pillars, or is that not relevant anymore?
The idea of this trilemma of decentralization, scalability, and security, was like very eloquently articulated by Vitalik a number of years ago, and really like got a lot of attention and mimetic mindshare. But I think over time that we've kind of seen, I feel like he's walked that back a little bit, or you don't hear about it quite as much, because I don't think it was ever intended to be like an absolute rule. Like, sometimes I think I see people misinterpreting it, where they're like, oh, the trilemma says that, there are these three considerations, and therefore if you have more of one, then you must be having less of the others. Almost like, tautologically, that must be the case. Whenever a project makes improvements that improve scalability, people are like, oh, it must be, less decentralized, because there had to have been a trade-off. And I think that...
Right.
Yeah, I think that Vitalik and others in the space, like that was never intended to say like it's an absolute. It's like these are the three, like you said, pillars that everyone is trying to optimize with hopefully better and better system designs. And a better system design would indeed offer like, more scalability without sacrificing on decentralization, or more decentralization without sacrificing on scalability, or like those are just the ways that you measure the goodness of a system, the usefulness of an innovation. And maybe the way to say it is like an innovation that just trades one for the other is not really an innovation. There's not a useful innovation. So I think that's the way to say it, is that there's an efficient frontier between, level of decentralization and level of scalability. And we're at a certain point on that frontier right now. And then hopefully the work that everyone is doing is going to help us go up and to the right on that efficient frontier curve, and get to a more efficient point, a more efficient curve.
Yeah, I like your answer. Just in general, before we dive into more of the details, what kind of application do you wish to attract, or meaning, we're talking about high frequency trading, and it seems like you want to tackle sort of that niche industry within what you're doing with Monad. There was a lot of talk in terms of optimizing the slippages, right, in DeFi trading compared to in TradFi. My question is this kind of optimization actually applicable to other industry use cases, or are you majorly having HFT in mind?
It's definitely not just HFT. I think at the end of the day, any consumer-facing app that actually gets traction among non-crypto natives and gets to a pretty high level of success relative to an iPhone app is going to need a lot of throughput. Like if you just think, run the numbers, like a successful iPhone app that has, say, 1 million daily active users, say that the average user is transacting 100 times per day. And maybe that's a lot, but depending on the kind of app, that might not actually be a lot. Like if it's a game, it's very easy to imagine that there's 100 transactions happening behind the scenes per day, per user. So that's 100 million transactions. But 100 million transactions per day is 1,000 transactions per second. I think one thing that happens is, because in the crypto space, everything is measured in transactions per second rather than transactions per day, we kind of lose sight of the scale of traditional tech applications. And, in traditional tech, everyone's talking about daily active users, and, it's a lot easier to reason. So yeah, just to say it again, 1 million daily active users, 100 transactions per user per day is obviously 100 million transactions per day, but that's 1,000 transactions per second. And from, what we've seen, like nothing right now delivers 1,000 transactions per second. 1,000 transactions per second is 100x the throughput of Ethereum right now. So, a lot is needed in order to help blockchains scale to the point where they're the back end for a successful consumer-facing app. And that's just one app. Like you could imagine that there's an entire ecosystem of apps that are coexisting and composing on top of one another. And yeah, I think it's clear that much more is needed.
Okay, so how exactly are you solving, how exactly you're going about everything in terms of, you talk about rebuilding the execution stack from the ground up. Can you just maybe first set the stage and explain, well, you've sort of alluded to some of the bottlenecks already in today's blockchains, but how are you solving it? How are you going about rebuilding from the ground up? And by all means, you can get as technical as you would like. It's a question for a long-winded answer. So
yeah. So most blockchain systems kind of consist of two major components, which are consensus and execution. Consensus is the problem of keeping hundreds or thousands of nodes in perfect sync with each other, so that they're all perfect replicas, while execution is the problem of actually executing the transactions, which are generally calling smart contracts. So executing the bytecode that each of those smart contracts is implemented as and making the appropriate state changes. In existing systems, there's generally pretty tight coupling between the execution component and the consensus component. And in particular, in most systems, execution is a prerequisite to consensus, meaning that when a block is about to be produced, the leader among all of these nodes basically executes the list of transactions and then produces a block, which is that list of transactions, and then kind of like a checksum of all of the state that is after those transactions have been executed. And the other nodes receive that block and then go execute the transactions as well, check that they got the same result, and then vote on whether or not they agree with that result. And then this voting, it kind of like, this is communication, again, across the world among geographically separate nodes. This voting goes on for a little while, and then at the end, the nodes come to consensus, finalize that block, and then move on to producing the next block. So that's kind of how a traditional blockchain system works. And I wanted to mention that just to set the stage for Monad, because a couple of the changes that our team has implemented have some different properties that ultimately allow that unblock a lot of existing bottlenecks. So I guess the four major innovations of Monad I'll describe really briefly. All kind of have a similar theme, which is the theme of pipelining. Pipelining is the practice of building stages of work that can occur in parallel while processing, I guess, like streams of work that might otherwise be sequential. So I think if you think about an oil pipeline, which is where I think the term came from, you could imagine sending some oil down the pipeline from the start and then waiting until it reaches the end point, and then before you start sending more oil down. Pipelining is the practice of building sort of like intermediate stations, I guess, that can receive like some of these like shipments of oil and then kind of like stage them and then send down the next stage of the pipeline when it frees up. So the act of putting these intermediate stages in there means that it's no longer the case that one has to wait until the first shipment gets all the way to the bottom of the pipeline before sending the next one down. Instead, you could, just send shipments down each like portion of the pipeline, as soon as the previous shipment clears from that stage of the pipeline. And you see this also in computers. Like the CPU maintains typically traditionally a 5-stage pipeline where in order to execute machine instructions, there's all these different stages for fetching the instruction, decoding it, executing it, updating the registers, and then committing stuff back to memory. These 5 stages allow multiple instructions to get executed in parallel, where each instruction's execution is sort of in different stages through that pipeline. Does that make sense?
Yeah, hence the parallelization.
Yeah, exactly.
Yeah.
So yeah, I think I wanted to mention those kind of these analogies, because I think that helps to explain
absolutely
the flavor of the changes that that our team is making in Monad.
Yes.
So ultimately, all 4 changes have this flavor of we have a process that is pretty like chunky in terms of the work that needs to get done, and if you wait until the work is completely done before starting on the next chunk, then it's just going to be pretty inefficient. So if we can somehow create sub-stages within there and then start working on the next unit of work, for the first stage for the second stage while the first stage is processing the next chunk of work, then, we can get stuff done a lot more efficiently.
That totally makes sense.
Cool. And so the 4 major areas where Monad introduces pipelining, I'll mention them really briefly. Pipelining within the actual consensus mechanism, pipelining between how consensus and execution interplay, and in particular creating, this 2-stage pipeline of have consensus first and then have execution. The third area of pipelining is in the optimistic parallel execution of transactions. And the fourth area of pipelining is pipelined state access. So we have a custom state database that, batches reads and writes and alleviates a big bottleneck in transaction execution, which is actually going to the SSD, pulling state associated with a particular smart contract. That's really inefficient. And this custom state DB that we've built is a lot more performant. So ultimately, all these changes allow basically the gas limit for transactions, for Ethereum transactions run on Monad to be much, much higher than it is on Ethereum, thus allowing the Monad system to process many more transactions in the same amount of time compared to Ethereum or other blockchains.
Yeah. Before I ask you, because you've talked about the pipelined execution system, and then wanted to ask you about your consensus, and you just mentioned the transactions. So you're aiming for 10,000 transactions per second. And what's the thesis behind that? Why 10,000?
Yeah, 10,000 is more just driven by the performance that we see.
Okay.
But it is a good, it's a good round number to come to market with the first version of Monad, because we think that it's the right scale where it makes a really meaningful difference for allowing decentralized applications to scale. This 10,000 transactions per second is about 1 billion transactions per day, which is on the order of payment processing systems like Visa, or, on the order of the number of messages that a major stock exchange or futures exchange ends up processing per day.
Right. What would be Monad's transaction finality? Has anyone asked you that question?
Transaction finality is single slot, meaning 1 second. You always hear about slots in the context of finality. So it just means that when a block is proposed by the leader, then all the other nodes go vote on it. And then once they come to consensus, meaning 2/3 of the network has agreed upon that block as being an official block, then at that point, the block is finalized, that official transaction order is finalized, and no reorgs are possible, meaning that there won't be another block that's produced at the same height. That block, that history is now enshrined into the official history of the blockchain. And that's a little bit different from Ethereum, which has roughly 12 to 18 minute finality. It's different from Solana, which has 32 slot finality, where I think each slot is about 400 milliseconds. So so about 10, 15 second ish finality for Solana. So just, the finality is quite fast.
Mm-hmm. So in terms of consensus, now that we're sort of getting into the topic, so as I understand, most of the existing consensus mechanisms are quote unquote leader based, and you just talked about the pipeline component before. So can you talk about how Monad, sorry, I think I keep mispronouncing the name.
It's my fault, actually, because I didn't really contest it at the beginning. So you're right that it's in the dictionary, it's monad, but we always say monad.
Monad, yeah.
So I guess let's go with monad.
I don't know why I put the emphasis on the mo. So like I said, as far as I understand, most of the existing mechanisms are leader-based. So how is Monad's different? What you were talking about, you have the sort of the pipeline flavor.
Mm-hmm. Monads is also leader-based. Mm-hmm. So Ethereum's consensus is leader-based. Solana's is leader-based.
Okay.
Algorand's is leader-based.
Yeah.
Tendermint is leader. Almost all blockchain systems are leader-based. And so there's sort of several major components. One is the leader election process. which is like how the schedule of, leaders ends up getting chosen. Typically in most systems, it's done periodically, like at the end of each epoch, where an epoch is typically like a day or, potentially a couple of days. That leader schedule is decided and then agreed upon by everyone. And then, everyone's just going to follow that in terms of, for the next day or for the next 3 days, how blocks are going to end up getting produced. I think that part is a little less interesting in Monad, so I'll kind of skip over that. But the second part is that, as you said, there's a rotating leader schedule. So when it's a particular node's turn to produce a block, and by the way, the Monad is a proof of stake system. So every node that wants to participate in consensus has to stake staking tokens in order to volunteer to be chosen as the leader. In order to like the leader election process is stake weighted. So the more that is staked, the more likely a node is going to be chosen to produce the next block and be the leader. Mm-hmm. Anyway, when a node is chosen as a leader, then there's sort of this choreographed dance that happens where that leader assembles a list of transactions that are going to be enshrined into history as the next, sequential list of transactions that happen. The leader sends that list as well as some other auxiliary data to all the other nodes in the system. To other nodes that are participating in consensus. So the other nodes that have staked tokens in order to participate. And then those other nodes basically send an acknowledgement back to the leader that they received that block proposal and that the proposal has valid signature and follows all the other validity checks. At that point, the leader assembles all of these acknowledgements into a thing called a quorum certificate, which is, basically like proof that all of these other nodes have received the original proposal and have acknowledged it, and sent a signed acknowledgement back to the leader. The leader, so again, like the leader sends out the proposal, the other nodes acknowledge it. Now the leader is assembling those acknowledgements into this thing called a quorum certificate, which the leader then sends out to all of the other nodes again. And then at that point, the nodes receive that. And then at that point, the nodes communicate to each other to vote on whether they vote yes or no on that proposal. And then their votes end up getting accumulated by the leader and packaged up. And if 2/3 of the stake weight has voted yes, then at that point, that's proof that that proposal has now reached that 2/3 consensus and is now officially enshrined into the blockchain. So that sort of sequence of, and it sounds more complicated than it maybe sounds like it needs to be, because, why isn't it, why was there that acknowledgement step? All of that is there basically as protection against a malicious actor. So in particular, it's very roughly speaking, the acknowledgement is there to establish that all the other nodes in the system have received the valid proposal, so they're able to vote. They're able to come to have a quorum, and then the second round of voting is there to actually do the voting. So ultimately, this is here for safety against kind of malicious behavior. For example, a leader only messaging the proposal out to a small subset of nodes, or part of the network coming under attack and not, being able to communicate outward due to getting DOS'd by an external actor or something like that.
Mm-hmm. And who can validate and run a validator node? Can anybody do that? Or would you need to be an experienced developer with, access to more sizable resources or whatnot? Or can it just be like anybody with a computer?
Right. It's a permissionless system. So anyone with a computer can download the node software, compile it for their machine, and run it. Mm-hmm. And when they run it, then, mm-hmm. Their machine becomes a Monad node and starts listening to network traffic and maintaining the state, updating the state. It's, completely permissionless. The only, other thing to point out is that in order to participate in consensus, one needs to stake tokens. So, you would need to acquire the tokens somehow and then stake them, or get other people to delegate their stake to you. And so there's a, kind of well-established set of business practices that validator companies have for, proving that they're really good at doing validation and contributing back to the community in the form of informational guides or, diagnosing issues, things like that ultimately build their reputability, which allow them to, show that they're a good validator that someone, should stake with. But yeah, there's sort of like multiple roles in this environment. One of them is the actual node runners, who then might be like, participating in this validation thing where they get other people to stake with them. But also, like, as just a normal end user, you don't have to run a node in order to participate in the network. Like, you can actually just delegate to other people, like delegate to one of these validation companies, one of these node runners, and then still contribute to the economic security of the network in that way.
Mm-hmm. Mm-hmm. You briefly alluded to the transaction costs that we all sort of face in the blockchain world. So high performance applications are obviously more gas heavy. What's your approach to transaction costs? And I don't know, feel free to give background understanding of the transaction cost challenge. It's totally up to you. But just curious, how is Monad tackling that?
Yeah. So I guess maybe the thing that I'll say is, when executing transactions, there are a couple of different resources that ultimately are the resources of the network that have to be taken into account. So one is the bandwidth of the individual nodes that are in the network. Another one is the computational capacity, like the CPU throughput. And then another one is the access to the actual state. So state is stored typically on SSDs on the nodes. SSDs are quite fast compared to hard disks, but they're still, on the order of like tens of microseconds to pull data from the SSD. So it's not completely free. And, blockchain systems that support smart contracts, starting with Ethereum, basically have a resource pricing mechanism where you can write a program that does anything, and then each of the individual opcodes in that program costs a certain amount of compute units in order to execute. And reading from disk, aka the S-load opcode in the Ethereum Virtual Machine, that costs more compute units than doing simple arithmetic like addition or subtraction does, because it's actually going to the disk to, make that call. And then, S-store, which is the opcode that puts data onto the disk, is even more expensive because it's doing a disk interaction and it's potentially, increasing the overall amount of state that's stored on the disk. It's consuming a limited resource. So, that's the design philosophy of the Ethereum compute costs, that we're just measuring the complexity, the amount of work that the systems are going to have to do, and charging users for it. That's the context for Ethereum compute units. And I call them compute units, but then the actual official term is gas. I just think that compute units are sort of more clear.
Yeah.
So I call them that. In Monad, we're making these compute units a lot cheaper because ultimately, just due to the different optimizations that our team has made, both to the actual execution and then also to the state storage and to other components of the system, it means that the system is capable of doing a lot more, and therefore, our expectation is that, for a given unit of time, like for 1 second period of time, the Monad system will be able to process a lot more work than Ethereum system does. So the compute unit limit per second will be much higher. So that's really, a long-winded way of explaining the question about costs, that at the end of the day with Ethereum, it's, resources are just, every transaction is the complexity from a compute unit perspective is just measured, and then there's a fixed amount of compute units available every second. It's about a million units of compute units, aka gas, per second. In the monad system, we also have this compute unit system, but the limit is just going to end up being much higher. We expect about 1,000x higher because of these improvements that we made that just allow us to do a lot more work.
Right. You strive for a much larger factor, so 1,000 times the throughput and 1,000 times cheaper fees. Did I do my homework correctly?
Right. Yeah, that's right. So the fees, that's the thing, is nobody really knows what the fees will ultimately end up being, because that's more just settled by the market.
Right.
But I think, intuition suggests that if there's a resource that's like very scarce, and a lot of the high cost of that resource is coming from the scarcity of it, which is true in Ethereum. Like there's more than 1 million gas of compute requested per second. But that's the maximum capacity of Ethereum. So, the price just kind of keeps getting bid up until it reaches equilibrium. And, a lot of users ultimately end up getting priced out of using Ethereum because they're not willing to pay whatever that market clearing price is for compute. So I think, intuition suggests that if, in an environment with 1,000x the gas limit, that cost should be at least 1,000x cheaper, probably more, honestly. But it's because you're going from a system that's very, very constrained with very high sort of like market bidding effects to one where there's, much, much less of a limitation on compute.
Oh, thanks for that. Just moving on, what's your view of AppChains? So just for our audience, those are application-specific blockchains or specialized layer 1 solutions. Do you think, will Monad adopt this approach? Are you looking into that? Is this something that you're considering? And if so, how would this work?
I think the context of how AppChains have gained some amount of popularity in the market, I would still say they're not really that popular, to be honest. I think the most prominent example right now is DYDX launching this Cosmos app chain, but it's not actually live yet. But I think the context of it is really that, for applications that kind of a modest level of adoption, then, when they're in an environment where gas is quite expensive and that cost becomes an impediment to their app going viral and getting used by a lot more users, then that's the point in time where, the team behind the app or the DAO starts to think about, moving to a new environment where that application's transactions are not competing with every other kind of transaction on the blockchain for block space. So it's really motivated by scarcity. It's really motivated by high costs. I personally think that most app developers don't want to maintain a decentralized validator set and have to go through, the procedure of when the network needs to upgrade and then getting all the validators to upgrade their code, to agree to upgrade their code at the same time, and dealing with, potential network outages, diagnosing bugs, taking patches from upstream. Because the app chain space is basically, there's a common piece of software. In the case of Cosmos chains, it's the Cosmos SDK GitHub repo. That's being constantly actively developed. And then the specific app chains are kind of pulling from that, like pulling their code and incorporating those changes into the specific app chain's source code. And so, it's not free, maintaining that. You have to, the individual developers on that individual app chain have to review changes that are coming from Cosmos SDK and say yeah, we think that this is safe. We're going to propagate this to this specific app chain. So just a lot of operational overhead. And I think that right now, maybe for certain teams that might be attractive just because the cost of gas is so high that, in Ethereum, that, it's worth it to maintain a separate environment where the transactions for that app don't have to compete with everyone else. But I think in an environment where, that's really the mission of Monad, is to push the limits of compute substantially forward so that then for all applications, for all users, it is extremely, extremely cheap use Monad, and therefore, or to build a decentralized application, and therefore, they won't have to take on this additional operational burden of maintaining a distributed validator set, deciding when to upgrade code, dealing with outages, all of this other stuff.
Just curious, how big is your team now?
Our team at Monad Labs is about 20 people right now. I think we're 22 officially.
Okay. And how many of those are devs? 99.9?
It's, I would say it's 14 of the 22.
Mm-hmm. This is super interesting, Keone. Just thinking, because you've definitely set out on a pretty important and very prominent mission. Just curious, what do you, at this point, you're in testnet, what would you say have been your biggest challenges?
I think the biggest challenges have been prioritizing, and this is maybe just a comment more generally about any early stage startup. There's like a myriad of things to work on. There's a lot of features that we think would be nice, but maybe not the absolute most pressing. So just sort of stripping down the effort to the most minimal thing that, still addresses the core issue that we perceive in the space, which is limited transaction throughput, and putting together that is the North Star, but then identifying like the sequence of all of the little things that need to get figured out in order to make that happen. That's been it's an execution challenge. And I think more generally, our space is still very, very young. It's still very new, because everything moves so fast. It feels like it's been in existence for a long time, but if you think about it, like Uniswap was only created in 2017, 2018. DeFi basically didn't exist until roughly that point in time. And then DeFi summer was like mid 2020, and then at that point, like everything was just so crazy that it's still only been a couple of years for DeFi, and only a couple of years for like usage at the scale where it's really breaking the limits of what exists right now. And it takes several years to enact real technological change. So I think that's like just an anecdote in general, is that I definitely feel this space is going to get more performant, more mature over time, but it takes time to make those changes.
Yeah, and just like I feel like I'm echoing sort of a cliche statement. We're super early, but it's all exponentially happening so fast. It's kind of hard to keep track of everything, even though some of us are have been in the space and are following, but it's just impossible to follow everything. But yeah, I like the fact that you're transparent in saying that organization and prioritization is a hurdle. Well, I think we're close to wrapping up, Keone. I hope I didn't exhaust you too much with picking your brain. So you are in testnet now, as far as I understand, and mainnet is on the horizon for 2024. Am I on the right track?
Yeah, mainnet's is absolutely on the horizon for mid 24. We're pre-testnet right now.
Oh, okay, pre-testnet.
So everything is just purely internal, but looking to ship the testnet by the end of the year.
Awesome. Well, is there anything that I have not asked or maybe have forgotten to ask that you'd like to add for our audience to take away? There's a lot that we covered.
Yeah, I agree with what you said about the fact that we are extremely early. I mean, I would just emphasize that, smart contracts haven't really been, adopted at scale up until pretty recently. And, a lot of best practices are still getting identified. There's also there's false starts and there's wrong turns in any kind of research. Like, with scientific research, there's so much stuff that I feel like the LK99, like the ambient superconductor stuff that was being talked about maybe a month ago or so, is a good example where there's just like so much research and so much R&D that goes on that doesn't really, it's just like, there's the LK99 people were working on that for like 20 years. And so I think that maybe one issue that I kind of see in the space is because everything is, publicized very heavily ahead of like release, and then everything is like so financialized, and then there's like it's a very like the build in public is good, but it's also it means that like the public is getting exposed to a lot of efforts like that are still at a very early stage in terms of maturity of the technology. So we do end up seeing a lot of these sort of false starts or focuses that end up changing over time, such as I think in the Ethereum scaling roadmap, like for a number of years, there's the plan to like focus on sharding as the end game. And then, more recently, like I think a couple of months ago, Ethereum changed their website to officially reflect that the approach is now very roll-up centric rather than sharding centric. They basically, put sharding to the side. So I think that, all of that is just to say that I think we will get to a place where there are really scalable decentralized apps and decentralized systems. There's still a number of problems to solve. I think some of the problems still to solve are user experience, like making it easy for people to interact with the blockchain without signing transactions every single time.
Right.
Mobile has to get a lot better. Fiat on-ramps, off-ramps have to get a lot better. Transaction throughput and gas fees have to get a lot better. And then security has to get a lot better. We can't have all of these DeFi hacks happening all the time.
Right, absolutely.
If we address all these issues, then we can get to the point where blockchain is the underlying financial rails, the underlying settlement rails for potentially all of finance. But we're very early right now because we're all kind of just, dog fooding this. We're trying, people are building new things and then we're trying them out. And I think as long as we have clear vision on what, as an industry we're trying to get to, and then what the problems are to solve in order to make that possible, and then different people who are working on different of those problems can have that level of focus where they are able to solve the specific, like one of those 5 or 6 things that really need to be solved, then that's the point where we won't be saying like we're super early. Like instead, we've ushered in this new technology at mass scale that does solve a lot of problems.
That was very well said. And I agree. And just like what you said in terms of science, there's certain concepts that have been worked on for years or decades. And like we say, science is never settled, right? So I think we could probably apply that to, not to say crypto space, because it always gets like a negative connotation, but just basically what we're trying to do here. And yeah, absolutely. I definitely agree with what you said. So, well, Keone, thanks so much for this conversation. What's the best way to follow your work or contact and, of course, or participate, et cetera? What's the best place people can either reach you or read up about your project? Besides listening to our podcast, of course.
Yep. Our website is monad.xyz. So that's monad.xyz. And then on Twitter, we're monad_XYZ. And then you could probably find me from there as well. But I'm Keone HD on Twitter, Keone HD.
Awesome. Well, Keone, thanks so much again for talking with me today and giving our audience a better understanding of Monad and its Layer 1 mission. Plus, you gave us a little direct high frequency trading 101 crash course for the people who are not familiar a bit. So I'd say keep up the focus. I think you got what it takes, and all the best with furthering testnet and then mainnet in 2024.
Awesome. Thanks so much for having me, Nina. I had a great time.
Sure thing. Thanks, Keone.
All right.
Thanks again to our guests, and thank you everyone for listening. Thanks also to the Bariam Music team for providing their music. You can check them out on bariammusic.com. All of the supporting information is on our website, blockchainrecorder.com. You can listen to us on Google, Apple, and Amazon podcasts, as well as on YouTube, Spotify, Radio Public, and Stitcher. You can follow us on Twitter and YouTube, where we are super grateful for your support. Stay tuned for our next episode.